This is a pre-built version of the application, and we will start by creating the database that this application will run against. So this database, and now let's go ahead and run the application. And the goal is that given this input data, so the speaker and the workshop and the room and the session time, the available session times. So given this data, we want to use genetic algorithms in order to find a schedule with no conflicts. So here we started from generation 0, where we had this as the fittest schedule, and it had 4 conflicts, and this is a table representation of that schedule, and those are the 4 conflicts. And for this simple application, a conflict can be one of 3 things. It can be a speaker assigned to speak at more than one workshop at the same time. It can also be a room occupied by more than one workshop at the same time, like here, those 3, room booking. Or it can be a speaker assigned to speak in 2 consecutive workshops. So here we have room 01. In those 2 sessions, they have the same session time. So WS02 and workshop 04. So workshop 02 or workshop 04. And speaker 02 is speaking at session time 04. So here, and he is also assigned to speak here for this workshop at session time 03. So we have 2 consecutive sessions booked for this speaker. And we go from generation 0 to generation so this is generation 20, where we found this schedule that has no conflicts, so this one. And here we are displaying this schedule from the session time perspective. So in day 1 from 8 to 9 we have those 2 workshops scheduled, and we have this speaker and this speaker in room 01 and in room 02, etc. And this is from the room perspective. So room 01 has those workshops assigned for it, and room 02 has those workshops. And from the speaker perspective, we have speaker 01. This person has those three sessions assigned to him. So workshop 01 and 08 and 17, and the speaker 02 has those three, etc. And this is from the workshop perspective. So this workshop 1 is on day 01 from 4 to 5 p.m. etc. I will start by creating a new project. And the domain of this application will contain a workshop class, and this class representing a speaker at the workshop, and this class will represent a room where the workshop can be scheduled, and this one will represent the time when the workshop can be scheduled. And this class will represent a specific workshop with a specific session time and a specific speaker and room. And a room will have an ID and a name, and they will both be initialized in the constructor, and we will have get methods for both. And since we will need to compare a room against other rooms, we will generate hash code and equals method. We'll use just the ID for that. And this should do it for this class. And a speaker will have an ID and a name, and they will both be initialized in the constructor, and we'll have get methods for both, and the toString method will return the name, and will generate hash code and equal method, since we will be comparing a speaker against other speakers. And this should do it for this class. Now a session time will have an ID and a time and a previous ID, and this will be used to check if a specific speaker have two consecutive sessions scheduled, and we will initialize all three of those in the constructor, and we'll have get methods for all. And since we will be comparing a session time against other session times, we'll have a hash code and an equals method, and they will be based off the ID. And this should do it for this class. And a workshop will have an ID and a name and a specific speaker, and they will be initialized in the constructor, all three of them. And we will have get methods, and the toString method will return the name of this workshop. And this should do it for this class. Now a session will have a specific ID and workshop and a speaker for that workshop, and they will be initialized in the constructor. And we will have get methods for those, and we'll have those two methods for setting the session time and the room, and we'll have two get methods for those. And the toString method will return the workshop ID and the room ID and the speaker ID and the session time ID that is associated with this session. And this class will create and populate the database, and this will have select statements to pick up data from the database and populate the domain objects. And this will be the name of the database, and it will contain five different tables. So a speaker table with an ID and a name, and a room table with an ID and a name also, and a session time table with an ID and a time and a previous ID. So for example, this session time 02 have this time, and the previous time is this one. The previous ID is this one, and same here, this is the previous for this one, etc. And this is the workshop table, and it has an ID and a name, and this is the workshop speaker table. So we'll have a workshop and its speaker, and a speaker can be speaking at several workshops. And this should do it for this class. and let's go here and pick up this SQLite driver, and go to properties and Java build path, and now let's try creating the database. Here we go. We do a refresh and we will have this class with a main method which will be driving the application. And this class will represent a workshop schedule, and this one a population of workshop schedules. And this will contain the genetic algorithm logic, including crossover, mutation, elitism, and this class will represent a conflict, which for this simple application can be one of three things: a speaker booking conflict, or a room booking conflict, or a speaker in consecutive sessions conflict. And a conflict will have a conflict type, and the sessions that this conflict is in between, and they both will be initialized in the constructor and will have get methods, and the toString method will return the conflict type and the sessions that this conflict is in between. And this code does select statements on the different tables in the database. So the room table, and the session time table, and the speaker table, and the workshop and workshop speaker tables. and it populates the domain objects. So the rooms and the speakers and the workshops and the session times. Initial data that this application is using. So here we have get methods for all four rooms, session times, speakers, and workshops. And to pick up the initial data from the database, we will need this DB manager. And this code will display the initial data coming from the database. So we will call this method from here. And let's go ahead and test run it for adding the rest of the code. So here we go. This is the initial data coming from the database. And a schedule will keep track of the session that this schedule is made up of, and the different conflicts between those sessions, and we'll need the DB manager to pick up the data from the database, and both the DB manager and the sessions are initialized in the constructor. And we also need to keep track of the fitness for this schedule, and this method does the initialization of all the sessions that are in this schedule. So we go through all the workshops coming from the database, and for each we instantiate a new session and randomly set its session time and its room, and then add it to the sessions that we are keeping track of. And here we have get methods for the sessions and for the conflicts, and the DB manager, and the toString method will return a string representation of each one of the sessions separated by commas. And this method will return all the session time IDs that are associated with a specific speaker. And this method calculates and returns the fitness for this schedule. So here we are instantiating a new conflicts, array list, which we are keeping track of here, and we check if we have a speaker in consecutive sessions conflict, and if so, we add that conflict to the conflicts array list. And here we check if we have a room booking conflict, and if so, we also add that to the conflicts list. And here we do the same for speaker booking conflict. So if we don't have any conflicts in the list, then we have 1 over 1, so we have a fitness of 1. And this method checks to see if the isFitness changed flag is true, and if so, it recalculates the fitness and sets that flag to false. And this should do it for this class. Now the population will keep track of all the schedules that are in that population, and we will initialize that list of schedules in the constructor given the size of the population and the data coming from the database. So here we are initializing new schedule and then adding each one to the list of schedules that we are keeping track of. And we will have a get method for schedules, and this does sorting by fitness on all the schedules that are in this population. Now we'll start the session numbering from 1, and this method displays the schedule as a table. And this one displays the conflicts given a schedule. And this one finds the fittest schedule given a population size. And we'll start the schedule numbering from 0. And call this method from here, and let's test run it for the initial population before evolving it. So we have the input data, and this is generation 0. So the fittest schedule have 5 conflicts, and this is a table representation of that fittest schedule, and those are the 5 different conflicts. And let's add those constants, and we will be using those here. So we'll pick up the data from the database using the DB manager, and we'll initialize it in the constructor, and we will evolve the population by doing a crossover and then a mutation to the crossed over population, and included in that is the use of elitism. So this method does crossover for the entire population and returns a crossed over population. And this method does a mutation for the entire population and returns a mutated population. So elite schedules are moved as is to the new generation. So here we only have one elite schedule. So we do the same thing in mutation also. We move the elite schedule as is from one generation to the next. And this will be the one with the highest fitness. And then we do a crossover on the remaining schedules in the population. And same thing for mutation. So this code. And crossover population uses tournament selection to select 2 schedules to do the crossover over, so schedule 1 and schedule 2. So we call this method 2 times. That does tournament selection. And the tournament selection size here is 3. So this method will randomly return 3 schedules given an initial population of schedules, which here has 9 schedules. And then we pick up the fittest of those 3 here and here. and we do crossover on those two schedules. And we only perform this operation if the crossover rate is bigger than mass.random. So here the crossover rate is 0.9. So we perform this operation 90% of the times. And here 50% of the times we are using schedule 1 and 50% of the time schedule 2. And here we do mutations on each one of the non-elite schedules, and we do that by calling the mutate schedule method. And we only make changes to the passed in schedule if the mutation rate is bigger than mass.random. And here it's 0.1. So 10% of the times. It should usually be smaller, but for the purpose of this application, we'll pick this value. Now those three methods display the schedule that we found with no conflicts from the room perspective, and the speaker perspective, and the session time perspective. And let's have this method that handles evolving the population from one generation to the next. And we'll keep track of the fittest schedule, and let's change this method. So now it returns a boolean, and here we are calling handle evolve population, and if we found a schedule with no conflicts, it returns true. So we set this flag accordingly. So we keep evolving the population until the fitness of that evolved population is 1, so it has no conflicts, which means we found a solution, and we set the fittest schedule accordingly. And this method calls evolve method in the genetic algorithm class, while we haven't found a schedule with zero conflicts. And if we found a schedule with zero conflict, then we display that schedule from the workshop perspective and from the session time perspective and the room perspective and the speaker perspective. And finally, let's go ahead and test run the application. So we started with this input data. So those are the available speakers, and those are the workshops in the system coming from the database, and those are the available rooms for scheduling, and those session times. So we have 2 days, and each one of those goes from 8 to 5, and each session is 1 hour. And we start from generation 0, where the fittest schedule had 4 conflicts, and this is a table representation of that schedule, and the 4 different conflicts are 3 room booking conflicts and 1 speaker in consecutive sessions conflict. So here room 02 is booked for 2 workshops, workshop 01 and 06, at the same session time, 16. And same for room 02 here has workshop 15 and 03 at session time 07. And room 01 has workshop 04 and 14 scheduled at the same time, session time 16. And here speaker 03 is scheduled to speak at this workshop, workshop 03. So on day 01 from 3 to 4, but this same person is scheduled to speak on day 01 also from 2 to 3. And we evolve the population, so generation 1 still have 4 conflicts, the fittest schedule, and we keep going. So generation 2 has 3 conflicts, and we keep going until generation 6. So this schedule has 0 conflicts, and this is a table representation of that schedule. So we found the solution in 7 generations, and this is that solution from the workshop perspective. And from the session time perspective. So for example, on day 01 from 11 to 12, we have those two workshops scheduled, workshop 09 and 13 in room 01 and room 02. And this is the solution from the room perspective. So room 01 have those workshops scheduled, and room 02 have those. And this is that solution from the speaker perspective. So speaker 01 has workshop 01 and workshop 08 and 17 scheduled at session time 08, 14 and 05. And speaker 02 have those workshops scheduled